We move on to question 20. State difference between DC and AC, and then we shall state three differences between resistance and reactance in an AC circuit. So I think the basic difference between DC and AC is about the direction of the current. So AC is a type that the current changes its direction periodically, but DC always flows in one direction. And as for the differences between resistance and reactance, we can conclude the differences throughout what we have learned before. So first of all is about the formula that we have learned about the reactance, such as the inductor is equal to omega L. For capacitor, it will be 1 over omega C. So the omega here is the 2 pi F, which is the depends on the frequency of the voltage. So first one, we can say that resistance is independent of voltage frequency, while reactance depends on the voltage frequency. Second thing is we learn about the phase shift in a AC circuit. So resistance does not induce the phase shift, but it is actually caused by the reactance. Next is about the power loss. So resistance causes power loss in the AC circuit, but reactance does not. So this is just sample answer from me. So if you have other answer, maybe you can just state it in the comment section below for further discussion. We move on to question C. A circuit consists of an inductor, resistor which connected in series to an alternating current supply shown in the circuit diagram below. So this is a RL circuit. We have the inductance 35 millihenry, resistance 5 ohm, AC current supply of root mean square voltage is 12 volt and a frequency of 50 hertz. So pretty straightforward. First, impedance in the circuit. So we need to obtain the reactance of the inductor, which is omega L. So we have the frequency 50, multiply the inductance 35 millihenry, and we have 1.75 ohm for the reactance. Then we apply the formula of the impedance, which is given as square root of R squared plus X squared. So just put in the value and we can obtain the impedance is 5.3 ohm. So second question is about the root mean square of the voltage across L. So we can apply V equal to IZ to obtain the current in the circuit is 2.26 ampere. And then we apply V equal to Ix to obtain the voltage is equal to 3.96 volt. So the question gives you the root mean square voltage. So we do not need to convert the value here, okay, as the answer should be also in root mean square already. So the next thing is the phase angle, which is quite straightforward. Just apply the formula of shift tangent XL over R, or if you have the voltage across the inductor against the voltage across the resistance. But since we do not have the value, so just apply this formula and we can obtain the angle is 19.3 degree. And the last one is the phasor diagram of the circuit. So this should be a common one that we have the voltage of the inductor is leading the voltage of the resistor. So the angle is here 19.3, which refer as the angle of the voltage in the circuit. So that's all for the section C of the past year in 2022. Thank you.